Sustainable architecture, also known as green architecture or eco-friendly architecture, aims to minimize the environmental impact of buildings and promote sustainability throughout the building's life cycle. It involves the integration of environmentally responsible design principles, energy-efficient technologies, and renewable materials to create buildings that are energy efficient, resource efficient, and environmentally sensitive. Here's how to design green buildings. Passive design strategies. Incorporate passive design strategies to optimize natural daylighting, passive heating and cooling, and natural ventilation in buildings. Orient buildings to maximize solar exposure, use shading devices to control solar heat gain, and design building envelopes with high thermal performance to reduce energy consumption. Energy-efficient design. Integrate energy-efficient design principles and technologies to minimize energy consumption and maximize energy efficiency in buildings. Incorporate energy-efficient lighting, heating, and cooling systems, employ energy-efficient appliances and equipment, and utilize renewable energy sources such as solar panels, wind turbines, or geothermal heat pumps to generate clean and renewable energy on site. Optimize building envelope. Design high-performance building envelopes with enhanced insulation, air sealing, and thermal mass to reduce heat loss, minimize thermal bridging, and improve indoor comfort and energy efficiency. Use sustainable and low-impact building materials such as recycled content, locally sourced materials, and low-emission materials to minimize environmental impact and promote resource conservation. Water efficiency. Implement water-efficient design strategies and technologies to reduce water consumption and promote water conservation in buildings. Install water-saving fixtures, such as low-flow toilets, faucets, and shower heads. Utilize rainwater harvesting systems, greywater recycling systems, and on-site wastewater treatment technologies to reuse and recycle water resources effectively. Site planning and landscaping. Incorporate sustainable site planning and landscaping practices to minimize site disturbance, preserve natural habitat, and promote biodiversity. Design with green infrastructure elements such as permeable paving, rain gardens, green roofs, and vegetated swales to manage stormwater runoff, reduce heat island effects, and enhance ecological resilience. Healthy indoor environment. Create healthy indoor environments by prioritizing indoor air quality, natural ventilation, and thermal comfort for building occupants. Specify low VOC, volatile organic compound, materials, formaldehyde-free products, and non-toxic finishes to improve indoor air quality and reduce exposure to harmful pollutants and allergens. Life cycle assessment. Conduct life cycle assessments, LCAs, to evaluate the environmental impacts of building materials, construction methods, and building operations over their entire life cycle. Select materials and construction techniques with lower environmental impacts, consider durability, recyclability, and embodied carbon emissions, and prioritize materials with third-party certifications such as Cradle to Cradle, C2C, or Environmental Product Declarations, EPDs. Adaptive reuse and retrofitting. Prioritize adaptive reuse, renovation, and retrofitting of existing buildings to minimize demolition and construction waste, preserve historic structures, and extend the lifespan of buildings. Upgrade existing buildings with energy-efficient retrofits, building envelope improvements, and renewable energy systems to improve energy performance and sustainability. Integrated design process. Adopt an integrated design process that fosters collaboration among architects, engineers, builders, and stakeholders throughout the design, construction, and operation phases of a building project. Incorporate interdisciplinary design charrettes, stakeholder workshops, and collaborative decision-making processes to integrate sustainability goals, optimize building performance, and achieve shared objectives. Post-occupancy evaluation. Conduct post-occupancy evaluations, POEs, to assess the performance and effectiveness of green building design strategies and technologies in real-world conditions. Monitor building energy use, water consumption, indoor air quality, occupant satisfaction, and environmental impacts over time, and use feedback to inform future design improvements and optimize building performance. By following these principles and strategies, architects, designers, and building professionals can design green buildings that are energy efficient, resource efficient, environmentally responsible, and conducive to the health and well-being of occupants, while minimizing environmental impact and promoting sustainability.